right, so here's some questions that I think we need to address for geometry at this point. The first one is getting an equation that looks like this, and how would we solve it? I notice it's a quadratic, and I want to get the quadratics equal to 0. So if we subtract 24 from both sides, now it's equal to 0. And this is the most basic kind of factoring that we look at. What multiplies to the last term, what adds to the middle term, what is the number pair? And I think it's going to be positive 8, negative 3. They multiply and add. And once you get to here, you want to set these individual binomials equal to 0. So for the first one, we'll get x equals negative 8. And for the second one, we'll get x equals positive 3. For the one to the right, we already have this quadratic equal to 0, which is great. However, there is a leading coefficient that isn't 1. There isn't anything even that would have multiplied to 10 to add to 17. So use that method of split middle term. 3 times 10 is 30. And then what multiplies to 30 and still adds up in the middle to 17. Try a lot of things. I know this is the winning pair. We're going to split that middle term. The 17x becomes 2x in 15x. Everything else will be exactly the same. And we have 4 terms. We'll go into groups. In this first group, the GCF is x. We take an x out of both of them, we get 3x plus 2. In the second term, the GCF is 5. Take a 5 out, we get 3x plus 2. This is possible, and if we're doing it correct, 3x plus 2, the same term should be in both of those binomials. So, in factored form, the GCFs go first, then the common term can go second. It could go the other way also, but here it is factored. And what does this mean? It means if you were to multiply this back out, x would get multiplied by both of those, which is what we're showing right here. 5 would get multiplied by both of those, which is what we're showing right there. In this completely factored form, then, I set this equal to 0, then x equals negative 5. I set the other one equal to 0. We would first of all subtract 2, then divide by 3, so we get negative 2/3 for our other solution. Next thing I wanted to look at was proportions, and what you do when you're trying to solve a proportion like this. I don't want to deal with the fraction, so if we multiplied both sides by 4, it would make that go gone. And if we multiply both sides by 7, it would eliminate the 7 in that denominator. Essentially, you're taking 7 times x plus 6, 7 times that entire quantity on the left side of the equal sign. And on the right, you're taking 3x times 4, which would have been just the product of this diagonal. 3x times 4 is 12x. So we multiply them, and we put them on opposite sides of an equal sign. You can cross multiply anytime you have a fraction equal to another fraction. So now to finish this one, we could subtract 7x from both sides. And now divide both sides by 5, so x is equal to 42 over 5. Another problem that I've been seeing is simplifying things incorrectly. So in a fraction like this, what I've seen is some people say, well, I can divide this and this both by 5. So you're saying that 5x plus 8 is equal to 1x plus 8 over 2. And I'll tell you that is not the same thing. You can't just divide a couple of terms by a number. You have to be able to divide everything in the numerator and everything in the denominator by that same number. And since 5 doesn't go evenly into 8, we can't do that. This will not simplify at all. You can't break it up individual pieces. Next thing, find the slope between these 2 points. So slope equals, we'll do k plus 3 minus 6. Notice I put parentheses around my entire quantity. It wasn't absolutely necessary for this one, but when we do 5 minus parentheses 8 minus k, that one is necessary because we're subtracting this entire quantity. Go a step further, it's k plus 3 minus 6, which would make that numerator k minus 3. And in the denominator, really 5 minus 8 and negative k, which makes it plus k. So if I look at all this, there's a positive k and there's a negative 3. Now, as I look at this, normally I'm done at this point, but because the numerator and denominator are identical, we could divide both of them by k minus 3. I'm dividing the entire binomial in the numerator and the denominator by k minus 3, which would actually simplify it down to 1 this time. Notice I didn't go in pieces and say k and k, 3 and 3. I divided the entire thing. Right, and our last one, the question is which lines are parallel to each other? It looks like L is parallel to K. It looks like A is parallel to B, but based off of the angle measurements we're giving, which lines are actually parallel? This 81 degrees is equal to that 81 degrees. So if I use my highlighter and highlight this angle, here is 81 degrees, and here is the other equal 81 degrees. And right now, I don't see them connecting with each other, but angles are made up of rays, so I could extend this side of the angle further, and now the two 81 degrees are connected. If I look at their location, they are corresponding angles with each other, and these corresponding angles are equal to each other, and their angles corresponding using this transversal of K, but they're connecting line A to line B, so A and B are the two that are parallel to each other. Since 80 degrees does not equal 81 degrees, since these corresponding angles are not equal to each other, we can't connect bottom to top. We can't say that K is parallel to L. In fact, they cannot be parallel.